Looking again at the situation, we have the point 1080, the point 10 plus delta t, 0.015 delta t squared, negative 1.85 delta t, and a plus 80. I've written it backwards from the way I wrote it before. We can see that our delta y is going to be the difference, this minus this. Now if we subtract 80 from 80 minus 1.85 delta t, etc., the 80 is going to go away, and it's just going to leave us the negative 1.85 delta t plus 0.015 delta t squared, which is what we have here. Okay, the delta y, the change in depth, the rise of our triangle is negative 1.85 delta t plus 0.015 times delta t squared. The run is, of course, simply delta t, so it becomes fairly easy to find the slope. Slope is just going to be rise over run, and when we do that, we're going to have negative 1.85 delta t plus 0.015 delta t squared, our rise, divided by delta t, our run. The delta t will divide into the delta t here, leaving us negative 1.85, and it'll also divide into the delta t squared. Remember that a division is a multiplication by a reciprocal. We have to distribute the division. Dividing this into this doesn't get rid of this delta t down here. We've also got to divide the delta t into the delta t squared, and we'll get 0.015 delta t. And if we simply look to the right, we see the result of our slope calculation, and we see that the slope of this triangle, starting at the clock time t equals 10.1080, is negative 1.85 plus 0.015 delta t. If we plug in delta t equals 20, remember in our first approximation we used clock times t equals 10 and t equals 30, where the delta t was 20. If we multiply 0.015 by 20, what do we get? We get 0.3. If we add 0.3 to negative 1.85, we get negative 1.55, which indeed was our slope as calculated over the 20-second time interval. Over the 2-second time interval, we would have 0.03 here if we plug in 0.2 for delta t. And adding 0.03 to negative 1.85 gives us the negative 1.82 we obtained before.